So this is a description regarding the mold. As we come to the discussion of the mold. So what is a mold? Simply we can say the mold is the connection from the injection unit is to the mold is by a part that is known as the nozzle. Actually, what consists of mold is having two halves, and necessarily we are having core and cavity. So any mold in injection molding process, we say it necessarily will have core and cavity, and inside the mold will have a channel that is connecting the stationary platen to the impression, or we can say there is a connection from the stationary plate that is known as the sprue channel, and we will have the sprue to be removed from the hardened or the solidified plastic from the mold during the injection of the material, and we will have a resin flow from the sprue to the impressions through runner inside the mold. So we will have a detailed description about the mold here. So this is we can say a zoom in view of what is being shown in the previous picture. We are having only mold here. Now if we see, we can have the cooling channels, as we have already mentioned, shown in the blue color. We are having the cavity. So this is the cavity side, and this is going to be the core side. So here we can have the cooling at the core side as well as the cavity side. And the plasticized material is coming from the nozzle. That is the end of the plasticizing region will have the nozzle, and the material is allowed to flow to the impression. And this particular region is known as the sprue. That is what we have mentioned. What is actually sprue? Sprue is the connection between the nozzle and the impression. That is simply we can say this is a particular schematic representation of a single impression mold. In a single impression mold, we will have only one product formed at one cycle, or during the one injection molding cycle, we will have only one product, that is known as a single impression mold. And in a single impression mold, commonly we will have a sprue that is connecting the nozzle to the impression. So this is what we have seen in the yellow color. Here is the solidified or the plasticized material, and here once the plasticized material comes into this impression, it will be cooled with the help of the cooling channels that we are having. So this is cooled, and once it is being cooled, we will open the mold and the part is to be removed. And here you can see, for removal of the part, we are having ejection pins. So these are ejection pins. So if you look at the picture, we can see that the pins are coming up to the product, and when the mold gets opened, this pin will eject the product out. That is why this is known as ejection pins. And the function is also being written here. These ejection pins strike the ejector plate when the mold is getting opened, and when it moves, the platen pulls away from the part. That is, we are having a positive movement of the ejector pins to remove the product out of the mold, or we can say out of the cavity or the core. So normally in a schematic representation here, you can see that this particular part that gives the inside shape to the product is normally known as the core half, and the part that gives external shape to the product is known as the cavity half. So here this is cavity half because this gives the external shape, and this is the core half because this gives the internal shape to the product. So normally we will have two halves which gives the internal shape and external shape. And normally in plastic injection molding, we will have the core half in the moving side. The reason is that due to the high thermal coefficient of expansion of the plastic material, when the plastic gets heated up, it is going to get expanded, and when it cools, it will be shrink. And normally in shrinking, what happens is that due to the shrinkage, it will catch hold onto the core. So that is why a positive ejection force is required from the core half, and in the 90% of the injection molds, this particular arrangement is being given. That is, the ejection element is normally placed at the core half, and normally the core half is the moving half of the mold. And this one is a schematic representation of a two-plate mold. That is the very simple or the most simplest type of injection mold that we normally use in industries. Normally we will have two-plate molds, and in a two-plate mold, this is again a schematic representation of the mold. We are having detailed description of different parts, and normally we will start from this end. That is, we'll have a locating ring for the mold. So this is the outermost part of a mold will have a locating ring. And what is going to be the function of the locating ring is very simple. We need to have the mold to be fixed firmly to the machine. So if the mold gets tilted in some way or other, that is going to affect the whole process. So it needs to be properly fixed onto the machine. Is how it is being done. It is being done with the help of the locating ring. So that is the basic function. We are having this locating ring to be connected to the machine. So this locating ring is a ring shaped metallic piece, and this will have proper connection with the machine part, and will have normally this connection comes with the stationary plate also. And just after just at the back side of this of the locating ring will have the fixed back plate. So that is what is being shown here. Just connecting to that, we will have the fixed back plate. So what is going to be the function is normally we'll call this as the cavity back plate also. So this is next to this, we are having the cavity plate, and this cavity plate needs to be fixed onto another plate, because normally when we discuss about two plate mold in injection molding process, we'll have two types of molds. As a general description, we say we'll have integer type and insert type molds. Integer type molds are nowadays not commonly used. What this figurative representation is insert type molds. So what is going to be the difference between integer and insert type molds? Simply to say, this is an assembled product, whereas this is an assembled mold. Whereas in the case of integer mold, that is going to be made from a single piece of metal, or we can say whether it is mild steel or hardened steel, we need to process one single piece of the mold plate to get all these arrangements intact. So that is practically very difficult, or we require very tedious works to be done onto that mold plate to get in a very good condition. That is why in industrial mold manufacturing, we normally will prefer to have insert type. And simply to say that we are having so many parts in a mold, but all these parts are assembled together to make a mold. That is why we said this is going to be inserting process. So we are having different parts inserted or assembled. So here in this case, we can see a fixed back plate just near to the locating ring. We are having a fixed back plate. Just near to that, we are having the cavity plate. So if you look at this, this is going to be a multiple impression mold, or simply we can say we are having at least two parts here. So when the process is completed, when the mold gets opened and the ejection is done, we'll have two products. That is why we say this is multiple, or we are having two products. One product is being shown here, the second product is shown here. And once the product is being molded, we'll have at least two products. That is why we say it's going to be a multiple impression mold, or multiple impression injection molding process. So here we are having this cavity plate on this. Why it is called cavity plate? Because the cavity that is going to be the external shape of the part. This is actually the part. External shape of the part is being given by the cavity plate. And here there is something known as the split line. And what is split line? It is nothing but the region where the mold halves comes and meets together. So here at this line, we can see that the core plate and cavity plate meets together. So there is a line that forms, that is a split line. So there is a line that goes on like this. This split line means we are having core and cavity. These two sides meets together in the split line. That is why it is known as split line. In the split line, the mold comes and close together. If there is, the mold gets separates also in that particular region. That is why it is known as the split line. And here in this process, we can have, just after the split line, we are having the core plate and the part inner shape that is being given by this. So this is going to be the core. This part is the core. Here actually this part is the core, and we are having the part that is being formed inside, and we are having the inner shape given by this the core, and the core is fixed onto a core plate, whereas the cavity is placed on the cavity plate. The core is actually, this is going to be a core insert that is fixed onto the core plate. So now coming back, or when we look at the other side, we can say two more things are very important. Things are being shown here. One is the sprue bush, and another one is the sprue. So what is the function of this screw is already been explained. What is going to be the function of this screw is it acts as the connecting channel between the injection region and the impression. So this is actually the impression 1 and impression 2, we can say. And we need to have a connection between the injection region and this impression. We are more focused on this impression because actually what the plastic product that we are intended to make will get from this impression. But the plastic material that is plasticized inside the injection unit needs to be transferred to this impression. So actually we can say this is a pathway or connecting way. This is going to be a connecting way. The screw will act as the connecting way. The metallic part is known as the screw bush, and the part that is being hardened, the plastic that hardens inside that the screw bush is known as the screw. And why this get hardened is because the mold is kept at a lower temperature, of course, for hardening the plastic material. So this screw will also get hardened inside, and we need to remove it. And for that, we will have a part that is known as the cold slug well, and the material is being stored here, and this will facilitate the easy removal of the screw out of the screw bush. So we need to remove this screw in every cycle. Why we require it to be removed? Otherwise, the pathway is going to be blocked. So our pathway needs to be opened. So after the product is at the time of the mold opening, we need to take out the screw out of the screw bush. For that, we are having a cold slug well, and we are having a screw puller also. So we are having a screw puller. Actually, the function is to pull the screw out of the screw bush. So that is why we are having a screw bush. And we are having, as we have already mentioned, we are having cooling channels. So here you can see big cooling channels are being drilled at the cavity side, and at the core side we are having a cooling channel that is being provided. And why this cooling is very important? Because we know, suppose we take the example of a thermoplastic material, say for an easy understanding, we take it as polyethylene. So polyethylene, when it is being plasticized, we need to take the temperature to a level of 200 degrees if it is high density polyethylene. So this plasticized material is now at 200 degrees Celsius. So the material at 200 degrees Celsius need to be taken to a temperature of nearly room temperature. So we are looking at maximum temperature near to 50 degrees. Room temperature means 30 degrees, which is very low temperature. So in the whole injection molding process, injection molding cycle, we are more focused on how to reduce the cycle time, because nowadays the process needs to be faster or even faster, and the sense that we need to manufacture maximum number of products. So maximum number of products means the cycle time should be as low as possible. So to reduce that time of processing, we need to have very efficient cooling system. So we are having the cooling system very near to the product, because here the maximum material comes in. So this cooling channel should be near to the product, and we are having cooling, and not only at one side, we are having cooling at the core side as well as the cavity side. So in the cavity side and the core side, we are having cooling channels, and we are having air vents also. So what is going to be the function of the vents in injection molding process is, again, the process of injection molding is done in a closed mold. That is very important. In a closed mold. So in a closed mold, of course, we'll have air. So when the material comes in, we are having air inside. So when the air inside the mold, if it remains there itself, it is very difficult for the plastic to enter into the mold or to the impression precisely. So if that is the case, we need to remove the whole air that is contained inside the mold, and we need to evacuate air. And how it is being done, we'll have very small channels at the split lines, will provide certain vents or very small channels for air to escape, and that provision is known as the air vents. We'll provide air vents in the split lines. Normally we'll have in the parting surfaces, we'll provide it. And we are having guide bushes in a mold. And what is the function of the guide bush? Is actually to guide the two pieces of the mold to get closed in a proper way. So guiding the opening and closing of the mold halves is done by the by the help of these guide bushes. We are having guide pillars also. So guide bush, guide pillar arrangement will help. So here having dowel or guide pin. The guide pin, guide bush arrangement is given on both the halves of the machine. That is, normally in injection molding process, this half is going to be fixed and this half is going to be moving. So the moving half and the fixed half, it should be working continuously in opening closing cycle. It should not get any fluctuation, or simply we can say any tilting. If it gets tilted very slightly, then the whole process is going to be out of order. So that is why we require to be in tandem operation in closing and opening. For that opening closing process, we'll have the gate pillar gate bush arrangement. Now, if that is the case, now we are having some other things that is kept beyond this. That is, if we are going to focus on the near to the core plate. So here we can see that just at the bottom side or the rear side of the core plate, we are having two support blocks. That is support block 1 and support block 2, we can see. And what is the function of the support block? We'll come to have a detailed discussion later. But beneath that, we are having the moving back plate. So we are going to have the whole system, that is the core plate is going to be fixed to a moving back plate. So this back plate is going to be fixed to the moving platen of the machine. So the machine we have mentioned, there is a stationary platen and a moving platen. So this is actually a mold, and there is a moving back plate. This back plate is going to be clamped onto the moving platen of the machine. And we are having again we are having a pushback pin. We'll have a discussion about the pushback pin similar to that of the support blocks. We are having an ejector pin. And what is going to the function of the ejector pin is easy to be understood. So the plastic is solidified inside the impression. Now we need the mold to be opened. So once the mold is opened, we need to remove the product out. So that is being facilitated by this ejector pin. So simply we can assume it like that. This pin move forward, then the part goes down. So this pin can have movement. It needs to have movement. And for this pin to move, we require some space. Otherwise, this pin cannot move forward and backward. So for that, we will have some space created, and that space is created by the support blocks. So when we have the support blocks, we will have some free space here. In that space, actually, this pin can move forward and backward, and that in that region is that is in between. We will call it as the ejector grid or the space. Ejector grid, actually inside the ejector grid, this ejector pin moves forward and backward, and we are having. Now we are having some parts associated. We'll have detailed discussion. But along with this ejector pin, we are having a pushback pin. So what is going to the function of the pushback pin is very important. So that means when we look at this process, once the ejector pin is out of the core, so suppose when the molding operation is over, the ejection is being done. Now the pin is out of the core. So this pin out of the core should be brought back to the original condition, or it should be brought back in the ejector grid. And for that, we are having this. When we look at the cross section, we can see that the ejector pins are of very smaller diameter, whereas this pushback pin is of larger dimension. And also, the critical part is the part that is actually the product is being formed. Out of that, we are having the pushback pin. So this pushback pin is intended to push the ejector pin back to this original place. It needs to take it back to the original place to continue the process. For that, we are having the pushback pin. So when the mold gets closed after one cycle, this pushback pin will hit the cavity plate, and when it hits, the whole system is arranged in a single plate. The whole plate, this particular ejector plate, ejector returning plate, etc., will be at the ahead position. It will be pushed back to the previous position, and we will have the ejector pin inside the core. That is the function of the pushback pin. That is why we are having a pushback pin here. And along with that, we are having some other things. We'll have a next picture. So this is actually the molding process, the mold opening cycle. We can see that this is how the operation goes on. This is a 3-plate mold, but still, when the mold opens, it is like this. So this is actually what we have mentioned. This is going to be the sprue, and the sprue is again going to be connected to the impression. So this is actually the product that we have already mentioned. We are having the product. So this is the connecting channel from the nozzle to the impression. So the whole system, we will call it as the feed system. So this whole system is actually the feeding system to the impression, and we call it as the feed system. This is our product. So this is the pin that comes out. As we already mentioned, the product is out of the mold.